is diabetes. It's a life-threatening disease in which there are high levels of sugar in the blood that are not monitored by the body. There are two types of diabetes. Type 1, in which the pancreas does not produce enough or any insulin. And then there's type 2, in which your body cells are not receptive to that insulin. Both of these types are dangerous, and so the person with diabetes has to monitor their blood sugar level. And to do so, they utilize the glucose monitor pictured below. So the current products are used that are traditional home blood sugar monitoring systems, Mini-Med, which is another glucose meter, but the most widely used glucose meter is the One Touch Ultra, whose accuracy we will be mimicking. Another product that our design is similar to is the Apple IVG Star, which includes the glucose monitor that can connect to the cell phone and that has the corresponding app. Our improvement upon the Apple IVG Star is that it's inexpensive and easy to use. And our device will utilize the 3.5 millimeter headphone jack pictured below, which is universal to any smart mobile device, as opposed to the 30-pin connector specific to only Apple products. Also, we are including a corresponding software application so that once our device is connects to the cell phone, this app will open up and the person can view their reading and save their data. One of our most prominent features is an online database, which when the person can choose to upload their information online, and then they can log into this database and have access to their data. And also their doctors or their care providers can also have login information, and then they can go online to this online database and view their information. So all these features together makes monitoring glucose easier, and to keep track of the data, it's also easier as opposed to conventionally people who have a diary and a planner to keep a record of their glucose report. So to begin measuring the glucose concentration, person will insert the test strip in the glucose monitor, and then they have a drop of blood inserted there. What happens is the test strip acts as the biosensor, and it uses an enzyme known as glucose oxidase, which oxidizes the glucose to gluconic acid. And then the charge mediator known as ferricyanide mediates this charge to the electrode surface, and the charge accumulated over there is the electric current that correlates to the glucose concentration that was input in the test strip.
Okay, so we designed a circuit to measure the glucose concentration of a blood sample. We incorporated a Wheatstone bridge in our circuit. So this is our circuit on the top, and this is the corresponding. So this is our circuit, and this is the corresponding Wheatstone bridge. Something we noticed during our testing is that the sensor, the resistance of the sensor changes with glucose concentration. So in our Wheatstone bridge, we treated the sensor as a resistor. So this, the test strip will connect here, and there will be 3 other resistors. So the resistance of the sensor will be changing due to blood glucose concentration. So the voltage difference of the Wheatstone bridge will also change. So here we have a graph of voltage output from the Wheatstone bridge over time for a few different concentrations. So you can see here, as the concentration increases, the voltage drop also increases. So we will be connecting in order to analyze the glucose concentration, we will be transferring these data to the microprocessor.
So this part of the circuit connects our sensor to the iPhone. It basically analyzes our data that we get from the voltage output from Wheatstone bridge, as you can see here. Basically, we decided to use an Arduino Uno with the 18MB328 processor just due to it's easy to use and code with. We set it up in a fashion so that We wait for, when there's no glucose on a test strip or our sensor is empty, our voltage output is pretty constant at 4. So we set up a trigger to monitor any changes that happen below 4 to set up our trigger. And then once it hits 0.8 seconds, we're taking a data point. So right here is where we're going to take our sample. And that voltage is what's going to correlate to our glucose concentrations on the iPhone. We send our signal on the output via frequency across our headphone jack, which we use a technique called frequency shift keying, which basically encodes a data in a modulated signal here. This isn't exactly what our data would look like, but it's basically either a 1 or a 0 in this example, and you can see how the frequency is going to change depending on the number.
So in order to develop our application, we decided to go with Apple because of their sensitive software developer kit called Xcode, which requires Objective-C programming. What the app does is it will take the sound wave from the microcontroller, interpret frequency as voltage, and then calculate glucose concentration from the voltage. It'll then automatically save the data with a timestamp onto the phone and upload it to a database online.
For our future work, we'd like to compact our circuit to a smaller size. Part of that process would be changing our microcontroller to something smaller. We use kind of a bulky one just to make sure that the process is easy. We'd also like to expand our market to the Androids, just because since we are using a headphone jack, we're compatible with Androids, and we'd like to market to people who own Androids as well. We'd also like to expand the range of our possible glucose concentrations that can be read accurately across our system. For the senior design project, we tested approximately 100 to 250 milligrams per deciliter. We'd also like to run tests with artificial blood and known glucose concentrations to calibrate the device.
So when we ran trials with glucose concentration, or like a glucose solution, just glucose and water, and compared it with our reading, the blue line on this graph represents our glucose input, and the red line was what we're giving the reading on the app was. So for our demo, we're going to do a blood sample. Taken from Anam. So you can see that most readings are listed below. Every time you open up the app, it'll be updated with whatever readings are taken. And we're just prepping.
Safety first.
So we'll be comparing this to the reading on the one touch. Oh, that does make sense. Another one touch.
It's not okay. Yeah.
Okay, so the one touch is reading 83 milligrams per deciliter.
It actually worked to within 2 or 3 deciliters of the one
Yesterday. Yeah.
All right,
Well, we can show you that on the night
No, literally, it worked yesterday. We did a demo.
The one touch worked yesterday?
The one tip always works. Ours did too, but we don't know what happened today. I need to review it.
So all you have to do is go to our online database, log in. This iPad is registered to user patient 1. So you log into patient 1, go to database, and all the readings we just took are present with a timestamp.
Those are extremely high.
Most of these were testing.
We were testing no glucose concentration. That's not me.
Your number was the same.
I was 80 something right now. I'm good. Engineering makes you get all types of diseases.
Yeah, questions.
How secure is the website that has all these databases? The big concern with like HIPAA, they get their files lost a lot. Like Kaiser, I know that they got their entire database hacked and they took all the patient's files and information, applied it for credit cards again. So I wonder.
The only information on the website are glucose readings and possibly their names. So if someone wanted to know how healthy someone was, that's like the worst that would come out of it. And I don't really know the security on WordPress.
It's just a login and password, so I'm sure it wouldn't be that hard to hack at this moment.
He is pretty cool. But where do you put your blood? Do you use a strip or do you use something else?
We're using the one for culture strips. Yeah.
So, honey, where do you put the strip?
And the connector is here.
The strip has electrodes on it, and the connector is just designed so that the wires will pick up the different. There's a reference electrode and the working electrode, and so the reference electrode goes ground.
So I guess what I'm getting to is how do you clean it, or do you have to?
Because the strips are disposable,
Yeah.
and all you do is kind of like hook the strip up to the wires and then take it out. So there's no easy clean. It's like it'd be the same as if you were changing resistors.
Any other questions?
Sometimes we're married from the line to the vessel. How do you ensure it's constantly?
That's all part of the script. Like, I don't think we didn't measure that because we didn't need to. Like, you just put the strip in and then you can. Yeah. It's all the same.
Making a new electrode, they're taking the strip which has the electrode, has all the chemicals in it.
Have you considered other connectivity options, such as Bluetooth or Wi-Fi or anything like that?
We can, but that wasn't our project, so we didn't focus on it. But yeah, I'm sure you could set it wirelessly, or the other companies send it through the 30-pin connector. So there's other methods of connection.